Hello, here we start chapter 3, polynomial functions. 3.1 is quadratic functions and models. Okay, first question is saying, it's not a question, it's a definition for polynomial functions actually. So, So here saying that let A here, let A and B let A be n a negative integer. It's supposed to be let A be n a negative integer, and let A sub n minus 1, A sub 2, A sub 1, A sub 0 be real numbers with what? With A is different from 0. So the function that's given by f of x equals to a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus a sub 2 x squared a sub 1 x plus a sub 0 is a polynomial function. So if you have anything written in this form, you can call it a polynomial function. Let's have some examples. Let's say I have 3x squared plus 2x squared minus 5. Here the x is 0. This is a polynomial. Let's say 4x to the power of 5 minus 10x squared plus 2x. This is another polynomial. So polynomials are this type of expressions. Okay, let's see what's the definition of a quadratic function. So, definition of a quadratic function is let a and b are real numbers with an a is 0. So the function that is given by ax squared plus bx plus c. Actually, when I say the function, then I'm supposed to say f of x equals to ax squared plus bx plus c is called, this type of function is called a quadratic function. I think now you are already familiar with what quadratic functions are. By the way, once we are talking about a polynomial function, this type of polynomial function is called with the degree of what? N. So it's important to know what's the degree in polynomials. See, degree is 3 here, the degree is 5. So don't forget about degree. So in quadratic functions, the degree is 2. It's quadratic. That means it's a square. Okay, let's see a little bit about graphs of quadratic functions. So once we're talking about these two graphs, let's call this figure 1. This is a figure 2. So here this one opens upward, right? So once you see that a graph is opening upward, you can know that this is for the quadratic function, which is ax squared plus bx plus c, but here a is greater than 0. That means the value of this a, the leading coefficient, is positive. Here this one opens downward, It's opening downward. It have the same function, which is ax squared plus bx plus c, but here a is negative, so the leading coefficient here is, it will be negative, so that's why it's opening downward. Okay, let's compare more graphs. Sketching graphs of quadratic functions. Compare the graphs of, let's say, first one. So let's start with the first one. It's saying compare y equals to x squared and f of x equals 1/3 of x squared. So first I will draw the y equal x squared. This graph is for y equal x squared. What if you sketch the graph for 1/3 of x squared? 1/3 x squared is going to be like this. So this is 1/3 x squared. So once you're drawing the 1/3 x squared, it's going to be broader and shorter. So to have a graph that is broader and shorter, you have to use this scale between 0 and the numbers that are between 0 and 1 will give you the scale of making a graph broader and shorter. It is shrinking here, the graph shrinked. Okay, let's go to the second. Comparing y equals to x squared. I'll just sketch y equals to x squared. Let's say that this is our y equals x squared, and I want to compare it with 2x squared. So here it will be opposite. It's going to be a bit narrower and longer. So this is 2x squared and this is just x squared. So whenever you are having here a coefficient that's greater than 1, it's going to make the graph narrower and taller a little bit. Okay, let's take more comparisons. Okay, let's say that I'm talking about this figure 1 now. You know that this is a parabola, which is y equals x squared. What if you have another graph this way? So now, what happened to this graph? First thing, you already know that the a, which is the leading coefficient, is negative. That means it will be x squared because it's bending downward. But what's the factor that will drag this graph 1 unit up? It's the plus 1. So this will be f of x equals to minus x squared plus 1. This plus 1 because it's dragged up by 1 unit, by 1 unit, and this negative is because it's reflected downwards. Alright, you already know that this is x squared. Let's say you have another graph which is let's say you have a graph like this. So what happened to the let's write the equation for this one. Let's try to find what's the equation of this graph. You know that it's dragged by how many units? By 3 units to the left. That means 3 units to the left. If you remember, we said x plus 3. We studied this in the shifting squared. No, 3. It's 2 units to the left. I'm sorry. It's 2 units to the left. So it's dragged here 2 units to the left. So it's going to be x plus 2, and it's dragged 3 units down. So once something is shifted down, it will be minus 3. So here you can say g of x equals to x plus 2 the whole squared minus 3. Okay, we'll have more examples on the next video.